Dear AS students, M1 students in specific, hi everyone again, and Ramadan Mubarak to all of you, and I wish you as always safe and well and your families. Alright, we are today in the second part of vectors. Last lesson we started with vectors, the last chapter in the syllabus of M1, and now for one or two lessons we'll finish the chapter of vectors. This lesson is deeper than the previous one. We did discuss how to write and find and describe the velocities and speeds, displacements as vectors, and how you find their magnitudes in vector notation. So we know that from the previous lesson that any vector can be written in ij notation. So when you write the velocity as the vector v is equal to ai plus bj, then the speed, the magnitude of the vector v, this is called the magnitude or the modulus, is the speed of the particle. Simple like this. And the same for d. If the vector d is equal to ai plus bj is the displacement traveled by a particle, then the magnitude of this displacement is the distance. This is the first part for today. Straightforward. Let's do the example to explain what do you mean by this. Let's use and apply. Find the speed of the particle moving with first part A, the velocity v1 is equal to 6i plus a j meter per second. The velocity v2 5i minus 12j kilometer per hour. So only we find the magnitude. The speed of the particle v1 is 6i plus 8 squared. Using the calculator you find it's 10 meter per second. So this is the speed of v1, or the speed. v2, the vector v2, finding the magnitude 5 squared plus minus or plus, because it will be squared, 12 squared, you will get 13 kilometer per hour. Example 2, find the speed and distance traveled by a particle moving with the first part velocity 3i plus 4j meter per second for 15 seconds. So this part A is consistent, the same units. So the first part we find the magnitude of this vector, which is 3 squared plus 4 squared under the square root, it's 5 meter per second. The distance, we know the distance equals speed times time. This is scalar. Scalar distance is a scalar. The magnitude of the vector is a scalar. Speed is a scalar. Time is a scalar. So distance equals speed times time, normal multiplication. The speed is 5 meter per second times 15 seconds given 75 meters. Part B, find the velocity. The velocity is 12 I minus 5j kilometer per hour for 30 minutes. So you are given the speed in kilometer per hour and time 30 minutes. We find the speed normally. That's 12 squared plus minus 5 squared, it's 13 kilometer per hour. We need the distance. We are free here, but better to convert 30 minutes into hours. 30 minutes is half an hour. Half an hour times 13 kilometer per hour, you will get 6.5 kilometer. We can convert the velocity kilometer per minute Yeah, but this is more straightforward. This is introduction, so we might be asked deeper than this, much like more complex questions, more difficult level of problems in M1 questions. So we discuss them now. We know that displacement is equal to velocity times time. In vector language, we call the displacement position vector at time t. So instead of saying displacement equals final position minus initial position equals vt, we know this before. We change the language only, the notation. This is the idea in this chapter and the problems in the exams. So the final position now will not be saying displacement only. So final position, it's the vector r, which is the position vector at time t. Instead of saying final position, we'll be saying the position vector at time t. Instead of saying initial position, r0 is the position vector at t0. So we may write, instead of final position minus initial position, r minus r0 is equal to vt. So this is the formula that mostly we'll be using in the questions of vectors in the exams and the past paper problems. Let's do some examples to explain how we do problems or questions on this. The next example is a particle P starts at the point with, look at the language now. A particle P starts at the point with position vector r0. This is straightforward. He tells us everything. P moves with velocity v meter per second. After t seconds, P is at the point with position vector, which is displacement before, the old language. So you are finding displacements here after t seconds. But we'll say now the position vector r at time t. So only be using this formula. R is equal to r0 plus vt. He gives us r0 in the question. It's 3I minus j. V is equal to, in the first part, negative 2I plus j. T is 5 seconds. So this is straightforward question. You write the formula R is equal to R0 plus Vt. Just replace R0 equals 3I minus j plus V, which is negative 2I plus j times 5, according to each case. So in the case A, we are given R0, V, and T to find R. This is that we want. So by expanding and simplifying, 3I minus j minus 10 by expanding here, minus 10I plus 5j, you will get minus 7I plus 4j. In part B, what does he want? Find the speed of P if R0, the speed. He wants the speed now. If R0 is 10I minus 5j, R minus 2I minus 9 plus 9j, and T is 4 seconds. He wants the speed. To find the speed, we have to find the vector velocity first. Using the same formula, we are given R, dear students, it's minus 2I plus 9j equals R0, which is 10I minus 5j plus 4, which is the time, times V. So make V the subject. V is equal to R minus R0 over T. by collecting like terms here. So minus 2i minus 10i plus 9j minus 4j minus 5j, you will get minus 12 over 4i minus 2 minus 10 is negative 12, or minus 12 over 4i plus 14 over 4j. This is the velocity. He wants the speed, dear students, or engineers, doctors in the future, inshallah. So, dear students, v, the speed of v is equal to negative 3 squared plus 3.5 squared to 3 significant figure. The speed is 4.61 meter per second. We're still in the easy questions, so we need to focus here. Part C, find T if R is equal to 12i minus 11j, R0 equals 4i plus j, and V is equal to, look, you are given the vectors, and he wants T, the scalar. Yes, he wants T is a scalar. We have to find the number, the value of T. So since we are given vectors, we write everything as using the formula. R minus R0 equals Vt. R is 12i minus 11j minus R0, so it will be minus 4i minus j is equal to 2i minus 3j times t. By simplifying this, 12i minus 4i is 8i minus 12j, do not see this equal, minus 12j is equal to 2i minus 3j t. Then what must we do? We find the magnitude for both. We calculate the magnitude for both, dear students, for both. We don't divide. Some students do a mistake here. We don't divide vectors by each other to find the scalar. So you find the magnitude for this, dividing by the magnitude of this value, vector multiplied by t. Find the magnitude in the calculator, you get 4 radical 13, the numerator, dividing by, so this will be cancelling out. You will get t is 4 seconds. Example 4. This is in M1 Excel book in specific. They are important questions. We may have harder problems. We'll do them in the last part. After we finish forces, after this part, then we'll do past paper problems. On problems on vectors. So you have to focus with the names, with the units, and need to read the question well. Okay, the question, the next example says, which is question 9, exercise 6F in the textbook. If someone have textbook, you can read and see, check the question there. At 2 p.m., the Coast Guard spots a rowing dinghy 500 meters due south of his observation point. Rowing dinghy, like small boat, and this is the one that floats on the water. The dinghy has constant velocity 2i plus 3j meter per second. At 2 p.m., the Coast Guard spots a rowing dinghy 500 meters due south of his observation point. So you are talking about, this is R0. He doesn't need to say this literally like at time 0. Observation point, the starting point. The dinghy has constant velocity 2i plus 3j meter per second. Find the position vector of the dinghy t seconds after 2 p.m. So what does he want here? We want here the vector r. the vector r. Since we are told that 500 meters due south from observation point means initially at the start, so at time 0. And since he said due south, remember, I'll remind you here, this is north, south. Let me write this more like neat here to be more neat. So this is north, south, west, east. This is I, dear students. This is J. This is negative I. This is negative J. So since he said due south, so we are negative 500 J. And V is equal to 2I plus 3J. We want the position vector at t seconds. I'm doing this in details because we're still introducing the first examples. So we want the position vector R, or displacement, sometimes we call it. So R is equal to R0 plus Vt. R0 is minus 500J plus 2I plus 3GT. Now we write this in IJ notation. Don't forget this fact, IJ notation. So we collect them. We put the I term or component plus J component. So by expanding here, 2Ti plus 3Tj, so 2Ti, it's the only term with I, minus 500 plus 3T, you will get 3T minus 500J. This is the position vector at t seconds after 2 p.m. which is the displacement in the language before at t or after t seconds or t seconds later, but or time later. Here we don't know, but he wants them in seconds. Part B, the distance of the dinghy from the observation point at 2 and 0.05 p.m. means 5 minutes. 0.5 p.m. we mean here 5 minutes after. Yes, 5 minutes after 2. So the distance, which is the magnitude of the displacement that we found here. So the magnitude of the vector R from 2 to 2.05 means after t, which is 5 minutes. Since he told us in the first part in seconds, so we convert the minutes, 5 minutes into seconds, you will get 300 seconds. Now by replacing 300 seconds in the value of t in the position vector, which stands for the displacement. Because of this, the magnitude of R gives us the distance. So the distance is equal to, after replacing t is equal to 300, so t, replace this t by 300, 2 times 300 plus 3 times 300, you will get 600 I plus 400J. This is R. So the distance is the magnitude of the vector, which is 600 squared plus 400 squared, almost 721 meters. The last example for today, which is important example, and most of times, not sometimes, the questions in the past papers, if they come like, we can say difficult. Students, they see these questions difficult, but we'll make them simple as we can. A particle A, question says, starts at the point with position vector 12i starts with. So this is r0 for the particle A, and initial velocity of A is minus I plus j meter per second, and it has acceleration 2I minus 4j meter per second squared. So you are given r0 for the particle A and its velocity and its acceleration. Another particle now, B, has initial velocity I meter per second and acceleration of 2j meter per second squared. After 3 seconds, the two particles collide, they meet, they collide. Find the speeds in part A, find the speeds of the two particles when they collide. When they collide. What do you mean by the particles collide? Means they meet at the same time, which is 3 seconds. It's the idea in this question. Good. So we know the time, 3 seconds. Particles will meet. Since we are given the velocity initial, u for each particle, initial velocity. So we can find their speeds then, using the old formula we know from the first chapter, v equals ua, u plus at. So va, better to write, we know this from the previous chapter and we explained this well. Be consistent, be convenient. Dear M1 students, the students, they do reset or they have older friends or brothers or relatives, they know this fact. We may get a low grade in M1 exams for inconvenience. So don't confuse yourself. When you are writing, saying, telling, V equals for particle A, write VA is better. VA equals UA plus AT. UA is given in the question minus I plus J. Acceleration is equal to 2I minus 4J. So VA equals minus I plus J, which is U, plus 2I minus 4J times 3. By simplifying and expanding, you will get velocity of the particle is 5I minus 11J. Minus 1 plus 6 is 5, plus 1 minus 12 is minus 11. So the speed of the particle A, 5 squared plus 11 squared, you will get 12.1 meter per second. We do the same. We are given U for B, which is I in the question. We are given A, the acceleration is 2J, and T is 3. This is the idea. How do you know T is 3? Because he said when they collide, and they do collide at T is 3, after 3 seconds. With T is 3, by replacing UB is I, AB is 2J times 3, so I plus 6J is the velocity of the particle B. So the speed of B is the magnitude of this vector, which is 1. We have 1 here. When you see I, 1 times I. Don't forget this fact. So 1 squared plus 6 squared, which is 6.08 meter per second. In part B, he wants to find the position vector of the point where the two particles collide. He wants the displacement. He wants the displacement. Be careful here, dear students. Many students, they think when they say find, when we say find, we mean work out the value. This is not true. We say find in mathematics or English mechanics, and our answer is a vector. Find the position vector. He wants the vector. All right. To find the position vector when they collide, we need to calculate the displacement at 3 seconds, because we don't know the displacement of A or B when they collide. Another point here, we do this calculation for particle A, dear students. Why? Because we are given the position vector for A, but we are not given the position vector initial, means displacement for B. So the idea in this part and the next part will be using the same fact. When they meet, their vector is the same because they meet at the same time. So we find RA. We find the position vector of the particle A and the instant of the collision at t is equal to 3 seconds. What does it equal to? RA equals R0 because it's given in the question, which is 12I plus 12J in the question, plus the displacement at 3 seconds. Can we calculate displacement at 3 seconds? Yes, of course, using the formulas of kinematics. Using SA, it's better to write SA, the displacement for A is equal to UA times T plus half A T squared. And we are given the U for A and the acceleration for A and the T, which is 3 seconds. So RA now, the position vector when they collide at 3 seconds, is equal to what? R0, its position vector 12I plus 12J plus U times T minus I plus J times T plus half times A times 3 squared, which is 9. By expanding and simplifying, you will get 12I plus 3 minus times minus I, so minus 3I. 9 times this, you will get plus 3J plus 9I minus 18J. So you will get at the end 12I minus 3I plus 9I, you will get 18I. 12J plus 3J is 15J minus 18J is minus 3J. So the position vector at the instant of collision is 18I minus 3J. And this is equal to introduce the last part, R of B as well, because they collide. So they have the same position vector then, because they do meet now at 3. So RA is equal to RB. And this will be used to solve the last part for today and for this question. He wants the position vector of B's starting point. And he wants the R0, the initial displacement or initial position vector, or he wants the position vector at time 0 for B, since we are not given the question here. So he asked us to find it in the last part. So as I told you, we use the fact that RA is equal to RB because they collide, and we calculate the same. We calculate the displacement for the particle B after 3 seconds. Since we know U is 3I from the question, we know that UB is I'll do another color to show it you, I meter per second, plus half A, which is 2J in the question, times 3 squared, which is 9. You will be getting 3I plus 9J meters. This displacement after 3 seconds of the particle B. So the position vector now, this is the meaning by RB is equal to R0 plus displacement after 3 seconds. Why we can write now RB, we know it since it's equal to RA that we found in the previous part. So RA is equal to RB, that equals to 18I minus 3J is equal to R0 that we want, plus the displacement in 3 seconds, which is 3I plus 9J make R0 the subject by moving this language that we don't agree with, but it helps by collecting like terms, or by moving between quotations 3i plus 9i to the other side. You will get 18i minus 3i plus negative 3i minus 9j. So R0, the initial position for the particle B is equal to 15i minus 12j meters. The idea is the same like we did in kinematics, but look at the answers. Most of them are vectors. We are finding and describing and writing our quantities of motion or components of motion as vectors. I hope I did explain this as simple as I could. Of course, we need more practice. After this, we will do forces, F equals ma in vector notation. After this, we'll do past paper problems to help you, to enable you to do difficult problems in M1 questions. We have more ideas, but we'll do them in more lessons. I wish you the best, dear students, always, and thank you so much.